Okie dokie, here we go. Continuing on in chapter 2, and we get to do some applied math, which means it's realistic and practical and all that good stuff. The good news is, is that you get your calculator back. Woohoo! That should make you all happy. Okay. Frankly, most adults use a calculator all the time because it's now attached to them all the time by way of their phone. So let's just be honest. In the real world, the numbers aren't beautiful. And as long as you have an idea of what should happen, kind of estimate it, use the tool to get the actual answer. So here we go. New notes packet, get it out. And here we go in the first part of chapter 2, section 6a. So this is mostly review, and then we're going to throw some algebra in there too. Ratios, rates, and proportions. Okay? Sweet. Well, here we go. Your learning target today. I can write and use, or I should say write. Yeah, write and use. Let's do that. Ratios, rates, unit rates, and solve proportions. Oofta, that's a lot. Yes, it is. Do you like a little snowman up there? I want snow so badly. My parents are getting about 13 inches today, and we're not getting any down here. Kind of sad. I like my snow. Keep your fingers crossed. Here we go. All right. Next, ratio. What on earth is a ratio? Well, it really is simply comparing two numbers. Okay. And how do we write that? Well, a lot of times we just write it like a fraction, like 1/2. That would be 1 to 2, 5 to 7, 5/7, 3 to 4, 3/4. But there are a few different ways that you can write it. Something like 6/11 or 6 to 11. Sometimes we'll use words, so we'll physically write 6 to 11. Sometimes we will write it as this way using this colon, 6 to 11, and you say it the same way, or you'd read it the same way. You do it like this, or you write it as a fraction, 6/11, and you might still say 6 to 11. Okay? All right. Now, let's take a look. My favorite thing on the planet is chocolate. And let's talk about, say you got one of those small bags of M&Ms. You still have leftovers from Halloween. What? Who has leftovers from Halloween? Eat the candy. Here we go. So let's say that in this bag, you have 32 M&Ms. Okay? And of those 32 M&Ms, you have 7 that are red, 9 that are brown, 6 are orange, 3 green, 5 blue, 2 yellow. Yes, that actually ends up adding up to 32. So if I asked you write the ratio of blue to brown, you'd say, well, blue, 5. So you could write it as this way, 5 to 9. You could write it in the words 5 to 9, or the fraction 5/9. Okay? Sometimes they might specify exactly how or what format they want it written in, but otherwise you can kind of choose which way you want to write it. Blue to all. Well, blue is 5, so you could say 5 to 32, or 5/32. Use the words. Yellow to all. Yellow is 2, which would be 2 to 32. You know what? You can put that in a more simplified form. 2 to 32 is the same or equivalent as saying 1 to 16. Okay, so if you can simplify it, simplify it. It might not always be as obvious when it's written this way, so think of the fraction, get it in simplest form. Same thing with yellow to orange, which would be 2 to 6. Think of that in simplest form as 1 to 3. Okay, awesome. All right, next, unit rates. What's a unit? Or rates and unit rates, actually. We better talk about a rate first. A rate is a ratio, so it's another comparing of two numbers, but this time there's different units, okay? So the last one, it was kind of M&Ms to M&Ms, so we just used the number. But if you have different units, then you would do it you call it a rate. So think of in Phi Ed, maybe you'll start calculating how many heartbeats per minute. Okay, the key word here, per. That's often what you think of. In the car, when you're shopping, you often think, how many miles per gallon does this vehicle get? What's the cost per ounce or something like that? So anytime you're thinking of that value, that's typically telling you it's a rate, okay? Different units. All right, well, then what's a unit rate? A unit rate is simply a rate, but now the denominator's 1. Okay, what does that mean? Okay, so let's say I calculate what my heart rate is, and let's say I get, all right, let's say I have something like 140 beats in 2 minutes, something like that. Okay, this is a rate because I have different units, heartbeats, minutes. A unit rate means basically divide these out, 70 beats per 1 minute. Okay, see I simplified or divided 140 divided by 2 gives me 70 over 1 beats per minute. This is now a unit rate because your denominator's 1. Okay, cool. All right, now is when we want to grab a calculator. Okay, so in taking a look at this guy, the population of the United States is about 300 million. I think I amped that up on your notes packet, didn't I? Because it's more than that. If there are 435 members in the House, what's the ratio of the population to the representatives? And actually, yeah, that's what I want to do. What's the rate? So you'd write, and what did I give you, like 324 million or something? I got to go grab your packet to look up that statistic. Go ahead and grab your calculator and start to calculate this out. Yeah, 324 million. Yikes. So for 324 million, now divide that by 435 because it's a fixed number of members in the House. Boom, 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 boom. Divide that by 435. Okay, so this is the representatives and this is the people. Okay. So what does this turn out to be when you divide this out? And I end up getting, let me get this back on full screen for you so it gets a little bigger. Okay, go ahead and crank it out and see what you come up with. 324 million divided by 435. Boom. Nice number, huh? Yikes. 744. So we'll kind of round this sucker off, all right? 744,820, let's call it 8, okay, per one representative. So there are approximately, each person in the House technically represents almost 750,000 people, okay? It's a big, large number of constituents they need to listen to when they're passing legislation in the House. Alrighty, look at this next one. You know I'm a hockey fan. This is probably 2 years ago, but let's look at Mikko Koivu's stats. 11 goals and 43 assists last season. That's probably in the 2015-16, 14-15 season. For a total of 54 points. He played 65 games, so sports uses a lot of stats. What's the rate of his points per game? Go ahead and grab your calculator. Points per game. So we're putting the points on top, the games on the bottom. It's always helpful to get your labels in the right spot. Points in the numerator, games in the denominator. Now, you're going to end up with something close to 1. It's not going to be exactly 1. You're going to get a lovely decimal here. But when it comes to hockey, having this kind of a percentage about, or shooting score, not shooting, but scoring. So around 83 hundredths points per game. Now I know that's impossible. You either score or you don't, but it's close to a point a game, which means he's out there and doing well. That's good. All right, next. Oh, we use this shopping all the time. Goodness sakes. What's a better buy? Take a look. This GIF or this GIF? Okay, go ahead and figure it out. Dollars per pound, $2.60 for the 2-pound can, or $6.54 for the 5-pound can. Multiply it out and see what you get. Go. If you were at my house when my kids were little, I just bought it in the biggest container possible because we would go through so much of it, for goodness sakes. It was ridiculous. Oh, 654 divided by 5. There we go. Ooh, look at how close these are. Now, I know that money typically doesn't go to the thousands place, but I'm going to use it here to compare. This is $1.30. If I add another decimal point there, these are really close, less than a penny per pound, but the small jar, believe it or not, is actually cheaper in this case, which is why you have to be a smart shopper. Let's take a look at this. If a 20-ounce bottle was $1.50 versus a 6-pack for $5.04, and knowing each can's 12 ounces, really what's cost-wise per ounce, what's the better deal? So the 20-ounce bottle, you're thinking that's $1.50 for 20 ounces versus, $5.04 for, hold on now, 6-pack. Each can is 12 ounces. That's 72 ounces. Figure those out. Okay. Now that top one, granted, I know you're only getting one container of it, but you get 0.075, so about 7.5 cents per ounce, versus this one, which at 504, and divide that by 72 ounces, we end up with just 7 cents an ounce. 0.07. There's a 0 in front there, sorry. Which they're very close, but actually the 6-pack's the better deal. Not by much, but do it. Okay, the next thing I want you to think of is when we're talking about proportions, okay? So let's move on, and I'll have you think of two fractions that are exactly the same as each other, okay? Mrs. Holm is interrupting me. What do you need? So come up with a couple, So think of something like 1/2 and 4/8, okay? There's two fractions that are the same. What's going on? Anytime you have fractions that are exactly equal to each other, they form what's called a proportion. So a proportion is a math sentence. It's an equation. You have to have an equal sign. And these two fractions are exactly the same. There's a neat property that happens with these, okay? And the neat property, okay, how can you tell? Do they make a proportion? Are these equal? Yeah, it works. Okay, I happen to know straight up in my head this works. 15/16, is that the same as 5/6? In simplest form, this gives me about, no. Actually, that is in simplest form. No. See, if I had 15, this would be 15/18 versus 15/16. That doesn't work, okay? Now, there is another way to check, okay? Is this a proportion? 6/8, 15/20? Yeah, it is. But how do you know? Well, one way is to say this is 3/4. This is 3/4. Yes, that's true. But there's another cool property that works, and that is this. If it really is a proportion, the cross products happen to be equal to each other, So 6 times 20, this numerator times this denominator, will also be equal to this denominator times this numerator. This is 120, this is 120. The fractions were exactly the same. Yes. So that's another way you can check to see if it truly is a proportion. Sometimes you can just see it. I know that 5/10 is 1/2. Boom. Yes. You can also, though, take note that the cross products will always also be equal if it's a proportion. On this one, which we said, it's not equal. 15 times 6 is 90. 16 times 5 is 80. They're not equal. It's not a proportion. Take a look at these two. Is this a proportion? Well, you can either get both of them in simplest form and see, or get a common denominator, see if they're equal, or look at the cross products. Okay? You could try and get this guy in simplest form. Say that's 3/8. Divide by 7, divide by 7. This is 3/8. So I would say, yes, indeed, that works. Or, since you have a calculator in your hand, you could check what's 30 times 56. Grab your handy dandy tool here and say 30 times 56. That's 1680. What's 21 and 80 on this side? 80 times 21. 80 times 21. I get 1680, 1680. Yep, they're equal. This is a proportion. Okay? The reason I have you practice that is because, yes, now we have a variable. Now, yes, sometimes you're going to see it, but algebraically, I want you to think of the cross products. 3 times x has to equal 5 times 21. Okay. Now, in the olden days, to solve this, I would divide by 3, and I wouldn't multiply 5 times 21 to get 105 and then divide by 3. I'd look at this and say 3 goes in there 7 times. Now in my numerator, I just get 35, and it works. That's what x is equal to. You might have been able to see on this one, I just multiply by 7, multiply by 7. Yep. But they're not always going to be that easy, okay? So let's take a look at this one. This one might not be obvious. It's a proportion because I have two fractions that are equal. So I know that 2 times 92 has to equal m times 46. Okay, now it's a straight up solve this. Divide both sides by 46. Now, in case you happen to notice, 46 is exactly half of 92, which means you should get exactly 4 for your answer. Because these fractions are actually 1/2 in disguise. Sweet. Okay, let's take a look at this one. Again, you might be able to see these, but there's a reason I'm having you practice this algebraically. Okay? Divide by 3. Divide by 3. 3 goes into 36 12 times. X is 84. Okay? Cool. Here's why I had you do this algebraically. Because you're going to see a few like this. Ooh. Ooh, ooh, ooh. Yes, on this one, 6 times 9. That's that cross product. That has to equal m minus 3 times 5. But you must wrap that m minus 3, because it's 2 terms, in parentheses. And now we have to distribute. Oh, hot diggity. So I get 5m minus 15 on this side. This is 54. Now go to town. And don't have a panic attack because your answer is not going to be a perfect whole number. Okay? That goes away. And you end up with this equaling 69, which we're going to have to divide by 5. And you should get m is something like 13 and 4/5, or 13 and 8/10, 13.8. This is when I would definitely be checking your answer, because this one is so not obvious. So 5/9 equals 6 over 13.8 minus 3. So 6 over 10.8. Ugh. Let's use technology to our advantage. If you press that numerator over denominator button and put in 6 over 10 and 8/10, mine gives me a decimal, and if I use the toggle switch, it turns it right into 5/9. Hot diggity, it works. So as gross as that is, that's actually the correct answer. Sweet. Here's your assignment for tomorrow. Okay? Pages 117 to 118 in the textbook. I'm chopping it a little bit for you. So go ahead and good luck. Show your work, even if you can see it.